Good afternoon, AP Stats. Today we're going to talk about 4.1, which is scatter plots and correlation. So to start, I'm going to create a graph with the explanatory variable graphed along the x-axis and the response variable graphed along the y-axis. Now, with scatter plots, we see a variety of little dots on my graph, preferably not those lines that I just drew. And when it looks like this, and it looks like it might have a positive slope, we call this a positive linear correlation. On the other hand, if I have little dots moving in a downwards type trend, we would call that negative linear correlation. The key here being linear correlation can exist. It does not have to exist. We might have these purple dots that go more like this, where it has that more quadratic shape. It could be cubic or any of those other kind of graphs you've learned about in previous math classes, but these would be examples of nonlinear correlation. And of course, there's one other type of correlation we want to mention. So let's start with drawing our graph again. And then here's the points on my scatter plot. There is no line that we could possibly draw through here that has any kind of slope, positive, negative. It does not model a quadratic, cubic, or any of those types of graphs. So we would say that this has no correlation. Okay? When we also talk about correlation in graphs that actually do have that correlation, there's different types beyond positive and negative. So those four types being perfect, strong, moderate, and weak. And how strong or perfect or weak a correlation is really depends on how close the dots are together. So let's first take a look at perfect, and we'll do that in pink. Perfect correlation is the dots on my scatter plot are literally in a straight line. Or as straight of one as we could draw. Kind of like that. That would be a perfect correlation. Okay, so we'll highlight perfect correlation. That's this graph. Strong correlation is going to be a similar idea, except for now, instead of being perfectly lined up, they're just going to be really close to forming a line. So it might look something like that. And I can draw a line of best fit through these, or most of these, but they're very, very close to the line. That's a strong correlation. When we talk about moderate, we're looking at something that we can tell that there's a little bit of an upward trend, but it's not anywhere as strong that we could draw a definitive line through and get most of the points or all the points. Weak is going to be even less together than this. Okay? I drew all of my correlations as positive correlations. We could also have perfect negative, strong negative, moderate negative, or weak negative. Okay? And part of how we determine whether a correlation is perfect, strong, moderate, or weak is by looking at something called the correlation coefficient. So the correlation coefficient we call R, and it's given by the summation of all the stuff divided by n-1, which we call our degrees of freedom. What all this stuff is we have our x observation minus our x bar, which is our sample mean, over our sample standard. And then we do the same idea with the y part of the points. So the y part of the observation minus y bar over the standard deviation of y. Of course, there is a way to do this on our calculator, which we'll look at. Some general rules about correlation coefficient. The closer R is to 1, positive or negative, the stronger the correlation is. Likewise, the closer R is to 0, the weaker the correlation is. Okay, so that's our general rule about correlation. And when we get that correlation coefficient, how do we interpret that? So go ahead and take a look at this example. We've got our number of sodas we're drinking in a week from however many people we surveyed, and we also get to know their bone density. Okay, so at 0 sodas a week, one person has a bone density of 0.893. The other person who drinks 0 sodas a week has a bone density of 0.882. We're going to go ahead, instead of using that formula, go ahead and do this on our calculator. So on your calculator, we're going to put our explanatory variable, in this case the number of sodas in a week, in L1, and we're going to put our response variable, or the bone density, in this case, in L2. So go ahead and take a second to do that. To graph, you're going to go to second stat plot, go over and select the one that looks like a scatter plot, and then if you press zoom stat, that should give you the look of the scatter plot. To do the correlation coefficient on your calculator, there's a few more steps that we have to follow. To do the correlation coefficient on your calculator, you're going to press second 0. That will open a catalog. You're going to scroll down till you see the D's, and you're going to say diagnostic on and hit enter. Once your diagnostic is on, it should be good until you reset your calculator. You may want to go through that every time you try to do this, just in case. Then you're going to go to stat, go over to calculate, go down to number 4, which is the linear regression, AX plus B. Click that. Your X list should be L1. Your Y list should be L2. You're going to hit calculator and enter. It'll give you an A value and a B value, which we will deal with in 4.2. You're interested in the R value. If you did not turn your diagnostic on, you will only get the A and B and not the R value. So make sure you turn on the diagnostic so that you can see your correlation coefficient. And that's all that chapter 4.1 is.